So this video is going to cover the law of sines, when we can use it, and some examples. So starting off with just one of the formulas, just like with law of sines, it's really important that we label our triangle, right? And we remember that, side A is across from angle A, side B is across from angle B, and side C is across from angle C. Okay, so we're all, you might not be given a triangle that's labeled, or maybe it'll be labeled with different letters, but you have to know what the formula is referring to. Okay, and we actually have 3 different versions of the formula. One for kind of each side and each angle. So we've got a squared equals b squared plus c squared minus 2bc times cosine of a. So this will be used, and let me see if I can pick a better color. This will be used when I'm looking for A, when I'm looking for side A or angle A. This one will be used when I'm looking for side B or angle B. And then this one will be used when I'm looking for side C or angle C. Okay, so just like with law of sines, we kind of, not only do we have to pick which one we're going to use, we have to pick which version of the formula or which part of the formula we're going to use. And also, just like law of sines, while this does allow us to find sides and angles of non-right triangles, we can't just do it with every single non-right triangle, right? We have to have specific pieces of information. So for law of cosines, the places we're going to use it is when we know 2 sides and the enclosed angle. So I like to call that side angle side, right? If we have a triangle and we know 2 of the sides, so let's say we know this side and this side. If we know the angle between them, the angle enclosed between them, that's side angle side, right? If we knew this, that would be side angle, which is law of sines. So this type of situation is when we know to use law of cosines. Okay, the other situation that would allow us to find all of the angles of a triangle is when we have all 3 sides. And we'll call that side, side, side. So if we have a triangle and we know what 3 of the sides are, then that means that we can use law of cosines to find any of the angles. So given this triangle, it looks like we have 3 sides, right? It tells us we have 3 sides, but also we can just see the 3 sides, right? We've got 7, 12, and 14. So this is going to be a side, side, side situation, which means we're going to use law of cosines. Now, it's like, duh, we're going to use law of cosines. This is a law of cosines video. But even if, the law of cosines and law of sines were all thrown together like they are on the maze, you can determine that this one is law of cosines because of the side, side, side. So the first thing I'm going to do is label everything. So I'm just going to, willy-nilly pick. I'm going to call this A, this B, and this C, which would make this side A, this side B, and this side C. Okay, and it looks like I'm looking for angle B then. So I'm going to go ahead and look back at my formulas, right? And if I look back at my formulas, the only problem that has angle, or the only formula, I should say, equation that has angle B in it is the second one right here. So that is the one I am going to use, right? It wouldn't be helpful to use either of the other ones because they don't have angle B in it, which is what I am looking for. So I'm going to write the formula down. B squared is what we should start with. B squared equals A squared plus C squared minus 2AC times cosine of B. Okay, you're welcome to just use the triangle to fill in the pieces, but it's never a bad idea to, think, okay, B, that's X, that's what we're looking for. I know that side A is 12, side B is 14, and side C is 7. Okay, it's never a bad idea to write it out like that so that when we fill it in, we can very clearly see what's going on. So we've got 14 squared equals 12 squared plus 7 squared minus 2 times 14 times 7 times cosine of b. Okay, now I know in the past I've gone on and on and on about how you want to keep it exact until the end so you don't really evaluate things, but when we're squaring something, that is exact, right? We're not rounding anywhere. 14 squared is exactly 196, right? 12 squared is 144, and 7 squared is 49. So we don't really have to be wary there when we're doing it. And this is also 196 because 2 times 7 is 14. So we can actually combine some things here because this is still exact. Now, a place where people really usually mess this one up is when they're simplifying. So 196 equals, I can combine 144 and 49 to get 193. Right? I can combine those, but I cannot combine 193 and 196. Okay, 193 is a number. 196, it has cosine of b attached to it, right? That would be like if you did this and said, oh, that's, negative 3x, right? These are not like terms, so we cannot combine them, right? So our goal now, since we're looking for what b is, our goal now is to isolate cosine of b, to undo what's being done to it. Okay, so let's take a look at that on a different page. So 193 is technically being added here, right? It's a positive 193 minus that entire term. It's almost as if we had 196 equals 193 minus 196x. The first thing we would do is subtract 193. Okay, and the rules apply here as well. I'm going to undo an adding of 193 by subtracting it from both sides. So that's going to give me 3 equals negative 196 times cosine of b. Okay, again, it can be really, really tempting to want to add 196 to both sides. But remember, we undo the operation with the opposite operation. So this is not a subtraction. If we were to add, we would have to add the whole term, right? This is a multiplication problem. This is 196 times cosine of b. So we undo multiplication with division. So we will divide, oops, I was on eraser. We will divide both sides by negative 196. Now, this you do want to leave exact, right? 3 divided by negative 196 is a repeating decimal, and we don't want repeating decimals in the middle of our problem. So we're just going to leave it as negative 3 over 196 is equal to cosine of b. And now this goes back to what we talked about a little bit in class with the warm-up as to properties of inverses. So we know if we have, function f of x and we have the inverse of f of x, the composition of a function and its inverse in, either way is going to leave us with just the input. So f inverse of f of x leaves us with just x. F of f inverse of x, again, leaves us with just x. So we're going to apply that idea with cosine and cosine inverse, because those are functions and they are inverses of each other. So I'll take cosine inverse of this side, cosine inverse of this side. Well, cosine inverse of cosine is b. And here, this is just something we'll type directly into our calculator, right? And what buttons will we hit? Well, we will do second cosine. First of all, making sure our calculator is in degree mode. Second cosine will have a little cosine inverse pop up, and I can draw that right here. So your calculator screen will look like this, cosine inverse, and then you just hit negative 3 divided by 196 close out that parenthesis, and you should get 90.877, which we are going to round to 90.9. So it's almost a right triangle. So close to being a right triangle, yet it's not. Which is why we had to use law of cosines rather than right triangle trig. Okay, now we could go back, now that we know that this is 90.9, we could now use law of sines to find the other sides, right? We could, I'm not going to do this, but say I asked you to, solve the entire triangle. Well, first I'd use law of cosines. I've got this, but now I can use law of sines. I can set this up to find whatever C is, right? Whatever angle C is. Then once I find angle C, I can use the fact that all angles add up to 180 to finish out, solving all pieces of the triangle. Okay, so you don't necessarily have to use law of cosines for all of it. Once you have enough information, you can kind of bounce between the two. So this one is a side angle side setup where we're trying to find the opposite side here. So again, just like last time, I'm going to label the sides so I can have a more clear picture of how this is going to solve out. And again, we kind of know we're going to use law of cosines here because this is a law of cosines video. But when determining between law of sines and law of cosines, this one is law of cosines because you can see pretty clearly here that we're given a side, an angle, and then the other side. Okay, so I'll just randomly label A, B, C. Okay, for fun, let's label it differently than last time. It could be A, B, C, like so. And then what we can do from there is label the sides. So across from angle A is side A. Across from angle B, side B. Across from angle C is side C. Okay? And so that means that we are looking for side A, right? Side A is our unknown. We know side B is 13 and side C is 24. And then also that angle A is 87 degrees. So if we look back at our formulas for this one, we're going to use this formula. Because not only does it have, A squared equal to it, but it has the angle in it we have, right? Technically these all have A in them, but it's pretty difficult to isolate A when it looks like this. This is already equal to A squared. So that's why we're going to use the A squared one. So here's our formula. Now we just have to fill it in. So we've got A is what we're looking for, so we'll leave that as A squared. You could also put X there. I don't care if you use A or X so long as you label your triangle. B is 13, so 13 squared plus C, which is 24, minus 2 times 13 times 24 cosine of 87 degrees. Now, let's simplify what we can simplify while still keeping it exact. So some things we can do, we can square 13, we can square 24, we can multiply 2 times 13 times 24, but we're going to leave cosine of 87 times 624 as a single term for right now, because it's going to give us an irrational number. So let's just combine, and this is all still equal to A squared. We can combine 169 plus 576. So now we have A squared equals 745 minus 624 cosine of 87. So now this is, from the first step, it was actually something we could put in our calculator. But from here, what we can do is try and get a by itself. A is being squared, right? So if we think of how we undo a square, it's by square rooting. But whatever we do to one side, we have to do to the other side. And let's pick up this problem on another page. So again, we took the square root of both sides because we're trying to solve for a, and we know, if you have something squared and you square root it, since those are inverse operations, it'll just leave us with x. So what I can do now is I just have a equals square root of 745 minus 624 cosine of 87 degrees. Okay, so this is now something you plug into your calculator. Now, normally we have a discussion about taking the positive or negative square root, or both of them. But since these are sides of a triangle, we always take the positive square root. Okay, because it's a length. It's not going to be negative. So again, this is something you'll type into your calculator. And let me kind of show you how. You'll hit square root, which on the school calculators is second square, x squared. So you'd hit second, then x squared, and that will have a square root will pop up on your calculator. So what you should see on your calculator screen right now is this. And then, you'll hit 745 minus 624, hit the cosine button, type 87, then close that parenthesis that the cosine started, but then you also have to close the parenthesis from the very beginning with the square root. Okay, so on your calculator screen, it should look like this. Okay, remember, again, we've got to close out both sets of parentheses. Then you hit enter, and you should get that a, let's round to the nearest hundredth, is going to be 26.69, whatever. It doesn't give us units, and that's going to be the side of that. Okay? And we're done. Those are your two types of law of cosine examples.